A function f is continuous at x equals c only when three conditions all hold together. First, f of c must be defined. Second, the limit of f of x as x approaches c must exist. Third, that limit must actually equal f of c. If any one of these fails, we get a discontinuity, and there are three main types. A removable discontinuity is when the limit exists, but f of c is either undefined or doesn't match it. A jump discontinuity is when the left-hand and right-hand limits both exist, but disagree with each other. And an infinite discontinuity is when f of x heads off to plus or minus infinity as x approaches c. Let's classify the discontinuity of f of x equals the quantity x squared minus 1 divided by the quantity x minus 1 at x equals 1. First, check f of 1 directly. Plugging in x equals 1 gives 1 minus 1 in the denominator, which is 0, so f of 1 is undefined, division by 0. Now factor the numerator. X squared minus 1 factors as the quantity x minus 1 times the quantity x plus 1. So f of x equals the quantity x minus 1 times the quantity x plus 1 divided by the quantity x minus 1, and for x not equal to 1, the x minus 1 factors cancel, leaving simply x plus 1. So the limit as x approaches 1 of f of x equals the limit of x plus 1, which is 1 plus 1 equals 2. So the limit does exist, and it equals 2. Now compare. The limit exists and equals 2, but f of 1 itself is undefined. Since the limit exists but the function value does not match it, this is a removable discontinuity. In fact, if we simply redefine f of 1 to be 2, the function becomes continuous at that point since all three conditions would then hold. Here's a quick trick for classifying these fast. If factoring lets you cancel the problem factor, it's removable. If the left and right hand limits disagree, it's a jump. And if the denominator goes to 0 while the numerator does not, it's an infinite discontinuity. A common trip-up, learners see that the limit exists and assume that's enough to prove continuity. Don't forget, you also have to check that the function is actually defined at that point, and that the two values, the limit and the function value, actually match. So the teaching tip is this: always run through the same fixed 3-question checklist out loud every single time. Is it defined? Does the limit exist? Do they match? Don't just eyeball the graph and guess.